Okay, let's give you guys some more practice. So determine if this series will converge or if it will diverge. So press pause and have a go. So there are lots of ways of doing this, but in order for any series to converge, the limit of this thing here must be zero. The limit must be zero in order for it to converge. So let's have a look at the limit of this thing as n heads towards infinity. As n heads towards infinity, the numerator will just act as 7 to the power of n. The denominator will act as 5 to the power of n. But then you can rewrite this as this. So here you've got a number that's bigger than 1, and then you power it as n heads towards infinity. As n heads towards infinity, for example, if you have 1.7, and then you keep on multiplying by itself, 1. Let's look at the case where it's to the power of 5. Then it's 1.7 times 1.7 times 1.7 what times, well, it's just going to keep on growing. So therefore, the limit of this will be infinity. So in order for a series to converge, the limit of this thing here, the limit must be zero. But here the limit is very, very big. So therefore we can conclude that this series will diverge. Okay. So next one. Next question here. So determine if this series will converge or if it will diverge. So press pause and have a go. Okay, so we could, well, as n heads towards infinity, the numerator will act as 2n. The denominator will act as n to the power 3. That's the same as 2 over n squared. So we can look at this series. We can take the 2 out because it's a constant. So we can compare it with this. Okay, so this, we know that it's going to converge. We've seen this many times. Well, we know that this will converge. Therefore, when you times 2, it will converge. But if you compare this with hang on, if you compare this with 1 over n squared, for example, here we know that if you look at the denominator, if you add something to the denominator, then the new thing here, this thing here, will well, if you're making the denominator bigger, then the whole thing here will be smaller. So when you add 1 to this denominator, then you can say that this will be less than this. Well, don't forget this thing we've seen earlier that we can well, if you make this comparison, you're trying to investigate this, and then if you're trying to compare it with this, well, we know that this thing here is going to converge. So here you've got if you look at this here, you've got something that converge. But then if you look at this is always bigger than this thing here. So this test here is useless, because here this will converge, and then but then if you look at this is always bigger than this. Well, bigger, it could converge or it could diverge. So this test here is useless. Okay, this test here is useless. What we should be using is this. What we should be using is the limit comparison test. So we are trying to investigate this. I will continue in the next video. Okay.